Covalent bonding is the next type of bonding that we're going to talk about in Unit 4. Covalent bonding is different in the fact that it's going to share electrons instead of transferring. So it's actually going to look more like this, to where we have like these two electrons that we're going to both share in order to have that full octet. So the key is sharing. These bonds are going to be made up of nonmetals. So it's going to be two nonmetals that are going to be bonding. So you can have nitrogen, oxygen, carbon, fluorine, iodine, any of those. These compounds have low melting points and boiling points. They can be very easily torn apart, and they do not conduct electricity very well. They're going to form what we call molecules, which are individual units that kind of look like this. So we're not going to have a crystal structure that forms like this box thing. We're actually just going to be making like these individual molecules. Some molecules that you might be familiar with: water is covalently bonded. You also have carbon dioxide. Those are some covalent bonds that you could be familiar with. And when we're naming covalent bonds, we're going to be using prefixes. So if there's one of them, so let's say we have like F, let's do H2O. So there's one oxygen here. So we would use mono for that oxygen. For two of them, we say di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So depending on what number there is for that element, that's the prefix that you use. The prefixes are going to be added at the beginning of the element name. So mono hydrogen or tri-nitrogen, any of those. And the name of the molecule is still going to end in IDE. So we're still going to have "ide" at the very end of this compound. Now, mono will only be used on the second element. We don't use it on the first one. We omit it if it's on the first one. And you'll see some examples. And also, charges don't matter. Yay. Okay, so let's do some of these examples. So we have N2F4. So we have 2 nitrogens and 4 fluorines. So I would say di for 2, dinitrogen. So 2 nitrogens, and then 4 fluorines. The prefix for 4 is tetra. So it'd be tetra, and you would have fluorine, but we do have to make it end in IDE, so it would be tetrafluoride as our naming for that one. So dinitrogen tetrafluoride is the name for that covalent compound. Now the second one, CO2. We have 1 carbon plus the 2 oxygens. Remember, we do not put mono on the first one, so instead we just say carbon. We don't even put any prefix. We just say regular old carbon because there's only one of them, and we don't put mono on the first one. The second part of this is 2 oxygens. So 2 is di, and oxygen is the last part. But we need to make it end in IDE, so we take off that last bit and we say oxide. So it's carbon dioxide is our covalent compound there, which you might be familiar with carbon dioxide. That's CO2. Our next one, CO. So we have 1 carbon, I'll do it over here, 1 carbon plus the 1 oxygen. Again, we do not put mono on the first one, so it's just carbon. But we do put mono on the second one, so we would say monoxide. Has to end in IDE, and here's our prefix for oxygen. That one's a little bit pushed in for the word. You don't see much of the oxygen going on there. It's just that X that contributes to it. And this last one, SiF4. So we have 1 silicone and 4 fluorines. So again, we do not put mono on the first one, so it's just silicon, no mono on that first one. And the prefix for 4 is tetra. So I would write tetra, and I know it needs to end in IDE, so it's going to be fluoride for that last one. So silicon tetrafluoride. Now going reverse is actually, I think, easier. So I don't see a prefix here, so that must mean there's only one sulfur. This must be oxygen, and the di means that there's two. So SO2 is the formula for sulfur dioxide. The next one, nitrogen, and there's tri, which means three of them. And then pentoxide, so I know that's oxygen, and penta is 5. So N3O5 is the formula for that. And then last, dihydrogen, so H2, monoxide, so that mono is 1 and oxide is oxygen. So it's just that H2O to finish out that covalent compound.